Good morning. Good morning. My name is Paul Bertucci, and I'm here to talk a little bit about laundry. All right, that will be the discussion of today. Cleaning your clothes. Well, in this case, it's going to be potentially your big data lakes that you're building. So I'd actually like to ask the crowd here a couple of quick questions. First of all, how many of you are actually doing any big data work? All right, so just give me a hand here. Okay, just a few. And on the Azure platform. On another platform, a couple, all right? So maybe Amazon or your own or what have you. Great. Okay, another quick question. For those here, who is doing any type of master data management or data quality in their enterprise? Doesn't have to be having to do with big data, just has to do within the enterprise. Oh, that's good. So I've got some interested parties here. Anybody using Microsoft's stack of MDS, DQS? Sorry? Starting to. It's early, yeah. Interesting stuff. And other master data management capabilities, like from Oracle. Any Oracle CDH or, okay. IBM's products. Yeah, there's an IBM. Anything from Informatica. All right, and specifically their data quality sets. Good, good. So that's a pretty good distribution. I do have a few slides here that I've got to do. They're obligatory, so I'll get to those in a sec, but you guys help me out on who's in front of me. But before I move past this page, I'd like to just stress that this is all about plugging data quality of service into your data lakes. So we're trying not to disturb it too much. We're actually trying to enhance it. And a lot of the discussion today will be architecturally and the key concepts that you have to go about doing. This is also based on a live production implementation that we did for a company I cannot tell you at, but you may get a sense of it by some of my data examples. And it's working, all right? And so it's possible. And so I came here to share what's possible, all right? And so we'll talk a lot about that story, some of the results, and so on. And I'll show you what my agenda is in a few minutes. I was told that the slides for this presentation are not on the session for some reason. You should be able to download those from there. And why they're not there, I have no clue. Apparently about 25 or 30% of the sessions didn't have the slides made it there. I'm sure they will show up at some point. If not, you just need to come and drop me a business card or write your email or something on something that I can get back to you on. And I'll just shoot it to you, all right? So, it'd be my pleasure. Good deal. So this is the cell phone one. You guys have learned these slides really well. So can you tell me what the next slide is? Oh. It's the resources, all right? Sounds good. And this is me. So just to let you know who's standing in front of you today, I have a consulting company, and I have offices in Europe and here. And so we do just predominantly data only. It's all about data. I am the author of the Unleashed series, the SQL Server Unleashed series from the very beginning. So whether, it's just that big fat orange book that you guys always see that you can't carry on an airplane because it's too heavy, all right? I actually use those as doorstops, so they work really well. Or monitor stands, all right? That's a really good one. The good news is with the Unleashed series, they started including a CD, a PDF on a CD in the book several years ago so that you can buy the book, get the CD, and then you've always got it, all right? So now it's available online, of course. My latest book is the High Availability Unleashed book, which you see on the top here. And that's actually on sale down at the bookstore, all right? So if there's any left. Apparently they were going pretty quick. So I have actually a lot of areas that I have had to dig deep in, big data being one of those, but things like high availability, overall architecture. I tend to be called an architect. In my former past, I was the chief data architect for Symantec for many years. and then the chief architect covering all architectural strategic stuff for Autodesk, and lots of other stuff. All right, so I've also written lots of courses and taught them, way back, including in the Sybase days. I was actually involved in the port of the Sybase kernel over to the OS2 platform of what would become the SQL Server. So that's how far back I go. I was part of that team, specifically on the optimizer side. So performance and tuning is in my DNA, all right? So anyway, one of the things that I've had the pleasure of also doing is an enormous amount of master data management. So it turns out that master data or data quality turns out to be almost the most important thing. All right, and that's likely why you guys are sitting here, because you want to see, because you can move lots of crap data around, and it's still crap, all right, unless you do something about it. Sorry? Amen. Yeah, and so I'm probably preaching to the choir today, but oops, better turn this baby off. And so I've actually been through massive implementations of things like the Oracle Master Data Management Suite and the IBM suites and a lot of those. And so that's some of the scars on my back, by the way. Some time ago, also several years ago, I got into the MDS, the Microsoft version of this, and then also got to know the designers and the product guys around MDS and DQS. And I'm going to mention another product during the presentation today, which is built off of and integrates with MDS. But I'm not here to actually tell you what's good or bad. That's always your decision, all right? So I'm going to tell you a story of what I was able to be a part of and implement for a very large multi-billion-dollar company. So here's basically what we're going to cover today. First of all, I want you to just fully understand what big data and the impact of that is all about. I'm going to talk about a fourth V. If you guys are big data guys, you know there are 3 Vs, right? So I'm going to talk about that, but I'm going to throw in a fourth and maybe a fifth, all right? We'll see. I'm going to present to you an architectural solution that is potentially useful for anyone in this room, and at least something for you to consider, and they show you how to plug data quality, I call it data quality as a service, into it. And then also some of the tools that we used along the way, all right? I'll talk a little bit about those tools. I've got a few screenshots and things. I was trying to consider doing a demo, but I could not get the data clean enough to be anonymized in order to present here. And so I wasn't given permission to do that. So I've got some screenshots, though, that will help kind of drive things home. I also want to show you how this affects your pipeline. In other words, where data quality fits into that. And obviously, a lot of discussions around the tools of the trade, all right? And more importantly is the results we got. So I'm going to share these results with you. They're based on quite a few, now almost 2 years of execution of that model. And so you kind of see where you get. You may be impressed, you may be disappointed, you may be whatever in those results. But I'm here to tell you that it's really a significant impact, and you'll improve what could be really bad to something that's really good, all right, from a data lake's point of view. And I'm going to turn this off, so give me a second. It keeps picking up my commands, right? Hello, Siri. Great. So let's talk a little bit about, expansion of big data, all right? So obviously, a lot of you in this room are doing big data. Some of you aren't, or you're about to. There's a traditional way of getting into big data. You don't just say, I'm going to do it. You start playing first, all right? So you guys have all, or some of you have gone through that sort of early adoption phase and so on. But why are you doing this is because you're being asked to try to leverage your big data. Now, big data is well, I've been around for a while, and I've always been dealing with big data. They just called it big data several years, a decade ago. So, I've worked for some of the biggest companies on the planet, and we had a lot of data, all right? So, and we were also getting it externally and producing it internally, and long before this big data fad came along, all right? So I'm sure you have all the same story. But what's good to know and understand is just the magnitude of what these are all about. So, I mean, here's the definition of what all of the petabytes, the exabytes, the zettabytes. But, you know, we're obviously, well, I think it's 21 zeros on a zettabyte, all right? So, and that's a very hard thing to actually even comprehend, but we're there already. And in fact, you know, this is the kind of, from an IDC's point of view, here's how, you know, where we are from how much we deal with already in this world, you know, and then also more importantly is how fast we're growing. So it's 4 zettabytes at the end of 2013, some time ago, 5 years ago. Well, that was actually a doubling in a year. And more than doubling, actually 200% from, you know, a couple of years earlier. And you can just see that it started, all right? And do you think this is going to continue? I'd guess so. And in fact, that's what this is really describing. In fact, here's a good chart also from IDC about exactly how that's gone, all right? And you know, where will it stop? It won't, all right? So we need to deal with that. So the interesting thing about this picture is, obviously we have a lot of data, but is this good data or bad data, all right? And that's always the question I ask. That's why I'm here to present today, because I don't care if I have 40 zettabytes of data. If I can't use it, it's useless to me, all right? So I'd prefer to make it more useful, all right? And you actually have a hand in that. So obviously the data avalanche is upon us, and we're going to get a lot of data going forward. Whether you produce that individually in your enterprise or you're bringing that from external sources, because a lot of people are buying data and feeding them in and streaming it in, that can become part of your big data platform. But you really don't want data quality to end the whole thing, all right? So in fact, I helped a company get into the big data platforms about 5 or 6 years ago, and one of the major criteria for success of that initial project was, is the data useful, all right? And one of the biggest criteria for that was the quality of that data. So in fact, that project didn't go past project stage, all right? Because the data was so bad that in fact the result, as pretty as it was in Hadoop and the wonderful things you can do across that, it was just borderline useful, all right? And it just wasn't good enough. And so they basically put it to sleep for a couple of years until they decided what they could do, and actually they got back into the data quality business. They decided that they had to do something about it. So don't let this be you, all right? So, but speaking of bad data, there is actually cost or impact associated with that. So here's actually some IBM estimates on the cost of bad data. I don't know if any of you have seen these kind of numbers before, but that's, let's see, trillions, all right? And that's just the US economy, all right? So the things that we're doing that are bad data related, that are having direct financial impact to potentially all of you guys, all right? So if you're working for an enterprise, is huge. And then I've heard the global estimates as well. It's basically about 10 times this, all right, number globally, because there's a lot going on outside of the US, and the systems tend to be less robust outside of that, so they get a lot of not clean data that they're having to work with. And then you ask, as part of this number, there was a survey, and so of the folks that were surveyed at the exec level, these are just kind of the reflection back of, like, do you trust your data, all right? So not many do. They've got that great data, but do they trust it? Well, that's because they haven't solved the problem. And, you know, 2 questions: do they trust their data, and do they, you know, believe the accuracy of it? So this actually applies to enterprise data or big data. And then the more we proliferate with the big data, this is really, you know, it's going to get messier, all right? So as we expand our data footprint, especially in the big data, it's going to have a bigger impact, all right? So I would assume you guys are following me and believe me on that. So it is. It's exploding. So here's my V's, all right? So obviously, from a big data point of view, we talk a lot about high volume. That's the V, the volume. We talk about the velocity. You guys know what the next one is? Variety, all right? So basically, we're getting a lot of data very quickly from a lot of places, and it's going to be of all different types and shapes, whether it's structured, semi-structured, or unstructured. That's kind of the paradigm around big data, to be able to handle that, all right? So great. And you really need to be able to surface this and surface it well to make obviously your decisions, your insights, your discoveries. We've got a lot of nice tools, new capabilities around AI, ML, and so on. That's great, but you're probably missing this piece, all right? And it's something called veracity, all right? Have you heard that term before? Veracity is all about data quality, all right? Can you trust that? Is it the right thing? And that's a hard question to answer. Or more importantly is, have you included it in your designs, in your architecture to address? And so that's really what you have to decide. So you'll hear me talk about veracity during discussion today. But I'd like you to just pick some tools to use. Go ahead, you just pick your tools. Which ones you got here? You probably will find some or more of your tools that you're using in your big data platforms. All right, see a couple of those? This is obviously a short list, all right? And that's the problem. There's so many tools. What do you do, all right? Well, obviously you have to make your own decisions on what you do. But there's a lot going on here, all right? So if you're a Microsoft side, you're probably deep into the Hortonworks side and so on, and the tools that are available there. But it can be, and any of these are fine, all right, for whatever purpose, all right? And so, but I want you to take away a couple of things. One of which is you have to understand what you're going to throw at your problem. Now, I don't know what your big data issue is or what you think you need to be doing with your big data, but are you using the right tools, all right? And it just kind of in general, these are some kind of high-level guiding points for you. Because if you're doing big data on a distributed model point of view, that fits certain type of data and certain type of use, all right? It's not everything. If all you need to do is horizontally scale because you have an enormous amount of data, you may not want to do it on a Hadoop platform. You may want to pick something else that is horizontally scalable. And so Microsoft Data Warehouse, the old, or the PDW, that's a great example of horizontally scalable architectures with distributed node concepts that scale into infinity because of the type of data. And so that's one of the first things I go into when I'm at a customer site is say, well, what are you trying to do, all right? Are you just trying to discover stuff about your data and it's all over the place and you're looking for, to do AI or ML, those kind of things? Or do you have more structured data but just huge amounts and you really want something that can serve that and then serve that up to the company for whatever reason? You'll go to completely different architectures or different solution sets, all right? So just keep that in mind. So that's actually something you need to go back and ask everybody, all right? Like, what are we trying to do here, all right? So, and it may be that you don't need to be on a Hadoop platform, all right? Maybe all you need is Teradata or Azure Data Warehouse, all right? Because that is what you need from how you deliver the data up. It's really structured data. You wanted to maybe, throw some dashboards and things right on top of that, all right? It's great, because that's not really going to be the case on a big data Hadoop platform. And more importantly is, ask the veracity question, all right? What are you doing about that? And in order to determine how much or more veracity you need, meaning getting that data the highest quality, you have to actually understand what your state is right now. Is my data clean enough or not? Do you know? I mean, you tell me, or is your big data clean? Yes? I have not found one person that can answer that question. More importantly is they don't know how to measure it. And then you have to actually develop a sort of an accuracy or integrity criteria list and say, does it meet this, all right? And then what are you going to do about it, all right? And so I had the pleasure of working with some with some customers that we went through that process and ended up coming with a solution and then solving it. All right, so it is possible. So moral of the story is, understand your problem first, decide where you need to be, make sure then that will change the architecture you put into place, and then and only then go pick the tools that you're going to need in order to do your big data, whatever, all right, for whatever purpose, all right? So just don't get the cart before the horse, all right? Make sense? Great. So one of the things I like to do is also give you a framework of what I call business intelligence and analytics platforms, because it's actually generic, but you'll see now where traditional platforms then grow to become or to embrace the big data platforms as well. Many people think of them as separate concepts, but they're not. It's all data, just a lot or unstructured versus what your legacy BI platforms may be, which is much more structured and, let's say, aggregated or dimensionalized. And so I like to put that all on one page and then put a purpose associated with that. So let me build up an interesting slide for you. So underneath everything, of course, everybody's got to get their security and access framework in place. That's just, that's necessary evil, right? As well as all the operational side, the monitoring, alerting, any workflowing you're doing, what have you. These are the things you have to have in place first before you start throwing stuff on top. And then any data integration or acquisition framework that brings data in and pushes it out, all right? So you're building on things that which make it deliverable. And then there's the traditional, or I call reactive type of platforms that you've put into place. And traditionally we call them the operational data. In other words, what did we do, all right? What we did. It's a reflection of transactional systems, but it's now there for reporting or analytics, or I should say for showing you what you did. Then the analytics side, which is really allowing you to put things in different perspectives, the typical forecasting or projection type of things that people want to have dashboards on. Here's what I did up to this point. Here's where it looks like it's headed, and so on, trends, et cetera. And there's a whole set of tools that you probably have all had to support and deal with, for years on that platform. Then there's the proactive, all right? It's now looking forward. It's getting into things like data mining. Who here has done any analysis services stuff on the SQL Server platform? Some of you, right? Well, in analysis services side, they have some data mining capabilities. And so you can do some things like affinity stuff, the clustering things, starting to shed light on like, oh, this data kind of looks like it belongs together. Well, we want to go lots further, all right? But that's really what the first part of the proactive stuff is. We really want to find out what other things might exist in that data, and why did that happen? All right, start answering some of those questions. And then moving further out is the predictive side, or even simulation and optimization. Who here has done any of that type of work? Simulation, optimization work. It's a rare thing, all right? So I've had a pleasure of doing some of that for Coca-Cola, actually. We were trying to build some really interesting things, like if you drop this, if you introduce a new product, how will that cannibalize another product, and so on. And it was pretty fascinating to see how all that works, but you need a lot of data to understand that. And so it's to see what's possible, and really to be more prescriptive. In other words, show me what I need to do to get this market share, all right? And that's possible now, I think even more than ever with big data and the proper capabilities, because we have so much data to be able to help us make those decisions. And of course, layer in the AI and the machine learning stuff to enhance that ability, and you're home free, all right? So this is an interesting way to look at capabilities that you want to build up in that world. Obviously, we're trying to bring in a lot of data. That's all the variety side on this picture. So wherever your data comes from, so whether it's internal data from your front office apps to your back office stuff, other internal systems that are there, Lots of maybe external data you want to bring in and mix with all this. Like maybe you purchase point of sale data from 3 or 4 different outside sources to bring in to see how your sales are doing and correlate that with what you believed and any other type of big data type of things streaming to you, social data, let's say, or other stuff. So all that's going to eventually, you want that to be able to be consumed in your data platforms. Traditionally speaking, there are, this is typically what we build out, and I'd venture to say that most of the people in front of me probably have something like this, where they've built out sort of predominantly the operational and analytics side, and they're using different methods to do that. Maybe you have a data warehouse or data marts, and those are aggregated, dimensionalized. Or maybe you have something called an operational data store, which is a reflection of the transactions that are happening in your transactional systems. But all that becomes part of what's available in your analytics platform, and lots of tools, all right? Click views, the business objects, the whatever you got. Then looking forward, there are some traditional products like the SPSS side that allow you to do certain other things, including the OLAP references, analytics, and analysis services, right? But where does big data come into this? Is it separate? No, it's just data, all right? So don't separate it, all right? It really interlaces into your current framework. Nothing different, it's extending it, it's making it more, all right? And that's where you're now addressing the other V's, the volume and the velocities. You're getting data pouring into you now. But don't think it's separate. It's not. It doesn't have to be, all right? You should be able to embrace both at once. And so think about it that way, all right? And as you can see, big data allows you to extend naturally all the way from the reactive to the proactive side because of what's there and what's possible with the tools that we have now. So you bring in your data, but then the last V I'm throwing in on the bottom, it's visible on these, is veracity. Don't forget about that, all right? Most people build out this, and then they've got a great, big pile of something, all right? So should I be using my technical terms here? All right, some of my technical terms begins with SH? No. Okay, I think I was told to keep my act clean here today. So add in that data quality layer, which includes actually a governance model, by the way. So, and introduction of concepts like data stewards. Okay, who's got data stewards in their organization? Okay, you guys shocked me. I expected one hand, all right? So life is good. This is great. I've never, ever been to a customer that had somebody that did data stewardship until I came there and told them they needed it, all right? And they go, oh, hey, you're right. Yeah, we need that, all right? Because they were basically embedding it in code and just hoping it worked, or just focusing on one, and then it was somebody's job there to keep an eye on that, all right? But they weren't really a data steward. I'll talk more about that in a little bit, because it's all about data quality. Great. So I just extended my legacy implementation. You see, I just added these dashed boxes. Well, it turns out what we found is, first of all, if we think about our big data as just another extension of our current data platform, our legacy investment, it turns out it also can enhance it. Because what we now gather out of the big data streams coming in, often we're able to put and share with those other legacy systems, especially if it's high quality. So we're actually able to extend the capabilities into these other areas of our existing already investment. We never knew we could do that before. And so it was like a bonus, all right, that we found. Because the data is there, we may only have it in a summarized form because it's not maybe as detailed, or we didn't want to share it out that way, but it's there. We can extend our current legacy investment to include more than it ever had before. Wow, that's great. So we're sort of like souping up our old investment. That's pretty cool. So traditional data pipeline, you guys have probably seen a slide like this 1,000 times if you're all into big data. But I mean, it's the mill, right? Acquisition, storage, analysis. That's the pipeline, right? I have this divided out into kind of capabilities from typical things you're using and doing in order to do these things, whether it's just the high volume stuff or it's high velocity, you're just getting streams of data coming in. These are the tools that you use on each step of the data pipeline. You guys have all seen a slide like this, right? So, and you probably have now your version, if you're choosing tools and using specific tools that fit into each of these stages of the data pipeline, right? So you're using, Scoop or Flume or what have you, depending on what type of data you're pulling in, and you're putting that on Hadoop or whatever, all right? So, and then doing a variety of things like using Hive or Pig or what have you, so in order to generate out what you're looking for. And then sharing those results. So, right, these are the 3 V's. And then I'm telling you, you need to also put this into your picture, all right? Wow, that's a big yellow warning, right? So, because again, I think I mentioned this earlier, if you don't do this, what you put out on the end isn't going to have the value. Oh, I threw another V at you. There's the value here, all right? So now we're up to 5 V's, all right? Maybe we can get to 6 soon. That's a big deal. If you can actually improve that data quality and increase that value to your end consumers, meaning the rest of your enterprise, that's what maybe could be the success or failure of your organization. It's all about data. Okay, good deal. So here's a question for you. Would you drink this? Great. Any volunteers? All right. So there's one back there. All right. Yeah. Well, that's another story. So this is the way I look at data coming in, especially external data that we've purchased or we're getting from some source. Maybe even inside what we have inside our data, what we're producing. So whether that's data we're streaming in from whatever we're doing, collecting from sensor data, what have you, whatever your data input concept is, I just look at it this way, all right, and then decide what to do about it. You can be proactive about that, or you can just not care and just be successful in your technical implementation, but unsuccessful in your business implementation. So I want you just to think about that. And from a data pipeline point of view, you really need to address this, I would say, at the data acquisition level or earlier, if you can. If you can hit it at the source, that's fine. Now think about the source for a second, and maybe not a big data point of view, but the further closer to the customer, wherever the source is, you can get data quality validation, the better you will be at the end, right? So, I'm sure you've been online ordering something, and up will come, well, you gave us this address, but wouldn't this be a little better representation? They'll say, choose from this one. It looks like it's USPS standard presentation. You all have probably done that, and you just say, yeah, that's the right thing. Well, when you do that, you actually are experiencing data quality at the glass, I call it, at the inception time, because you've actually helped them out, whoever they were, in making sure that your address was correct. All right? In fact, it's actually standard, all right? And we'll talk about some key concepts like that a little bit later as we go through this. Big data, you don't have that luxury. Sorry to disappoint you, but you can't go back so far to where that data is getting created necessarily and impose validation and workflow. That's just, and so you better do, but you can still do things about it, all right? And that's really what we discovered in the example I'm going to show you today, all right? So, but I just wanted you to understand that that's, depending on what you have, that kind of a thing is available at different points in time. So let's talk about big data. And actually some of the things that I've had the pleasure of being involved with. The one that I'm really going to show you a little bit about today is something we did in the high-tech arena. I can't talk about the company I did this, but it was all about gathering data from a variety of different external sources, mirroring that with internal data, and then making sense of it in a Hadoop platform, all right? And introducing the whole concept of data quality as a service. all right? And because it was wild. It was a wild, crazy thing from all the different sources globally. And we had to basically make sense of it. I had also a pleasure of dealing with something really in the healthcare industry that would be called patient population health. We're basically streaming or pulling data from a large number of different provider concepts and networks, and actually be able to watch people as they go after services and understand their health reasons why they were engaging in the population. And then actually be able to make some interesting observations about, in general, proactive things to do, to offer to customers, those kind of things. It was really fascinating. And lastly, on the financial services side, this was really interesting. Not that any of you would ever be motivated by money, but doing a pretty big, intense stock portfolio management analysis from a lot of data over about a decade and a half worth of historical data across a lot of different markets, and being able to come up with some really fascinating insights into investment portfolios and such to meet individual customers' needs and resources. That was a lot of fun. So let's talk about really, I say it's a disturbing pattern that it's emerged in big data, but it was always there to begin with. So I'm just trying to emphasize it right now. So traditionally, we have lots of different sources for our data that we're going to pull in and throw into our big data platforms, right? Great. So what do? You just grab it and throw it in. You've got your big data platform all built out. That was easy, all right? Just spin up some lakes, right? So that is so easy, all right? And it's getting easier and easier. So that's great. But what do you do with this data? Well, some of that data is, I say, unidentified, all right? They're just mishmash. They're crap. And so you try to sort those out before you really, want to move forward with them, because there's a lot of, from all your sources, there's going to be data that's just not useful, all right? So you have to deal with that. And then there's obviously no data governance, all right? So you're just throwing data in, and you don't have somebody like a data steward or even a governance model sitting on top of that, likely, because you're just playing with it, or it just hasn't been thought to do. And more importantly is you're not fixing anything, all right? Because big data as it comes in, by definition, is not updatable. You don't go fix stuff in your data lakes. It's just there to be reading, right? If you are thinking that you need to update data in your data lake, you're not doing the right thing. It's not what its purpose is. You're going against its design. That's not what it's there for. You're talking about a transactional system now, all right, which will support updates and deletes and those kind of things. So what do you do when you need to fix data? Typically, you do it on query, all right? It's termed, all right? You add in, like, exceptions, like, don't think about those, skip those, or what have you. Well, that is, by definition, a rat's nest, all right, or whatever. So I hope you're successful with that, all right? Good luck. So don't call me, by the way. I don't want a part of that. Anyway, this is what I see over and over, all right? This is how it's being approached. And so what do you end up with? You still end up with dirty data, all right? And maybe a little better, but it's all embedded, perhaps. It's on query, et cetera. So it's just kind of rough. You really need to do something to change that. More importantly is, how do you even identify what's good data versus bad data? Yeah, you guys tell me. All looks good, right? It's not, all right? Well, by at least at the minimum, it's going to be inconsistent, incomplete, or have some variation that you have to deal with, because not everybody calls the same product the same, or there'll be some slight differences in a customer's name, or what have you. By definition, it's a mess, all right? So if you're not doing anything about it, you aren't going to be, I'm going to suggest, not tell you, that you may not be as successful as you'd like. So what do you do about that? Well, let's add data quality as a service into that picture. Same beginning, same platform, but now we're going to throw in a whole new concept. And this is the way I want you to come away from this presentation. So if you remember this one slide, I did my job. all right? So don't mess up your big data platform. Build an extension to it, which I call data quality as a service. And then you are then going to fulfill certain kinds of things. The first thing is any data that's coming in that is needing cleansing or any kind of data quality work will be shot to this data quality as a service. Just think of it as a plugin, all right? And well, I'll tell you in a couple of slides, that means basically when you're just creating this platform to begin with, all data needs to go through this. But there's some interesting phenomena that will occur later on, which I'll show you with some numbers. Then you also are able to bring in and start getting smart about what you're doing. So for instance, I'm going to introduce something today called fuzzy matching, which is an important critical aspect of identifying things that look the same or what have you, so that you know that you don't have, or when you've got something like a product, and even though it's under three different, it's been represented 3 different ways or 100 different ways, you can actually match them and say, it's the same product, all right? Or it's the same customer, or whatever, okay? The data quality service traditionally is built around a concept of something to master, something to create a quality representation of, typically customer or product or other types of things that you want to have absolutely correct, that actually drive all of your downstream requirements from an analysis. And then more importantly, it's a place where you can accumulate knowledge that is happening about your data in one place and not have to go to all of the different places that data may emanate from. Because the goal is to get something drinkable out of that. By the way, the picture on the left-hand side, the dirty water, what is that? Anybody want to take a guess? What does it look like to you? Oil, yeah. Oil from what? No, this is actually a picture of a sample taken from the Gulf oil spill back on, in the day. That's the origin of this picture. And you're right, it's a mess. I wouldn't be drinking that water, all right? So, good deal. So let me describe to you a possible architecture for you to utilize that now embraces the concept of building a data quality as a service capability for you. Okay, this is actually something that's been running in production for almost 2.5 years now with a lot of success. I'll share some of the results, statistics about this as well. But the front end, or the data source stuff, basically looks like this, all right? So we've got, I'm building out a little bit of, you can see my cursor here, I'm building out a lot of the types of data sources that we were consuming, all right? And a lot of enterprise data we brought in, believe it or not, we brought it into the big data because we wanted it to use. We wanted to leverage that. So we brought in all kinds of data we had internally, like marketing data and customer data, because we had that already from years of gathering in traditional systems. And including some of there's even an MDM reference here, which they had already implemented a master data management capability using the Oracle product around customers, but that also became a source for us to use. Our implementation ended up using Microsoft's MDS capability coupled with another add-on product. I'll talk about that in a minute. We also externally, we're pulling in data. In this case, it was point-of-sale data from around the globe for computers and other devices that contained the commodity that this company made, all right? This company that will remain nameless. And all the advertising data in all media types, whether it was published, on TV or what have you. So there's a lot of source of data coming from every place on the planet, all right? And that's the big data part. And then also a lot of social data from a couple of places, particularly Google and Twitter for certain types of trending, all right? And so one of the things that we decided to do was create architecturally what is called a staging and data acquisition platform. So this is not just a single Hadoop implementation where it's one big platform and a series of lakes. We're segregating this for purpose, right? In this case, it's going to be there and on a big data platform for the strict purpose of bringing my data in its raw form and then fulfilling all of data acquisition needs up until we have the data in one place. And so it's a key component. So here's what we would have in this first fully self-contained platform. We would have what I call raw data, which is basically any of the data that's coming in from any source, all right, before anything's done with it. Then existing data, well, once you get it there and you've done something to it, it becomes existing data from this platform's point of view. And that's going to be important. I'll show you in a minute, all right? It's just like there's this epiphany we came across in order to make the whole thing go. We also had a chance to bring in enrichment data. Anybody do enrichment of their data in their platforms? And I'll give a little better example of what enrichment means, but this data was in such a raw form, we wanted more associated with everything we were getting, so we had a chance to add more to the value of the data lake we were building, and that's the enrichment part. And then I already mentioned the enterprise data. We were bringing in things like marketing data and customer data internally that we already had, all right? So that's what we're going to bring all of this into this first platform. And that's where a lot of the magic occurs. Then on a separate big data platform, which I call the data delivery platform, notice it's green colored. There's a color theme here. But we will move data forward into that. And then this becomes the platform where we want you to do things with. We want to publish from here. We want you to use it from an AI or ML point of view. Because I don't want you to do it on this one, because it's in process, in progress. But here, I hope I've got my act together. We just had to figure out how to do that, that's all. And then this is literally where you publish out of. You can spin off cubes, you can do, you name it, you can do it here, all right? And it's where everything is available now, and it have hopefully been uplifted because I introduced data quality as a service to the picture. So this is kind of a high-level picture of what we built, and successfully. So I'll break that down in a bit. But let me talk to you a little bit about what's in this first piece. The first piece, I say raw data, because that's really how all data starts, all right? So everything pouring into this, initially, before we do anything, I just call raw. But within it, I have basically two sets of tables, all right? So we used Hive underneath all this, and we had a raw table and what we would call a stage table. And then you basically, you got to utilize both instances. And one place captured it, we decided what to do with it, then it migrated forward within the single platform and enhanced it and quantified it and just determined whether we needed to master it or not, whether it needed cleansing or not. And I'll share some of that with you. But we introduced a term called conformed, all right? Ever heard that term before? Conforming means really you've done work on this thing and it's met a set of criteria. Maybe it's been matched with something that already existed. It's been deduped, cleansed. Maybe it's been hierarchically reconciled, whatever the heck that means. I'll show you what that is. You're utilizing things like taxonomies. You're doing standardizing your data. You're defaulting data that didn't exist before. There's a lot of goodies here that you can get into. When it's done that, this is done in that existing reference, all right, existing data reference. Then you've got something now that's starting to look a lot more consumable. The enriched part, well, you guys, I don't have to explain that, all right? You also have an opportunity to add and extend existing data with other information. I'll show you an example of that. And then I already mentioned that we were also pulling from our enterprise. In general, the enterprise data was in pretty good shape because they have certain bars they have to answer to. So that was a pleasure. I don't know what your current enterprise data is, whether it's good or bad or whatever. We had the privilege of, or the luxury of having some pretty good stuff because they wanted it like squeaky clean, all the stuff they could handle on their structured data. So we were able to leverage that. On the data delivery platform, basically it contains what I would say is normalized, I'll explain that in a bit, conformed, and enriched data. That's the stuff you want to publish out, all right? Not what's in staging, only what's in the data delivery platform, all right? So that was never, the data staging acquisition was never exposed to anyone other than for our internal use. The only thing they'd ever see is when data drops in I call it the DDP, all right? And it's green, all right? Because we did something to it. So the other thing is, what we did, and I'll have a couple of things to explain on this slide, but we discovered there's a dial concept that's available to you. Because not only did we have the original data that came in from its raw form in our data delivery platform, we had the conformed data with it. We basically just had the raw data and then all of the conformed components, the attributes, the things that you would use to master or were changed, like maybe address information or what have you. We just concatenated it on. That became what was available in the data delivery platform, including any hierarchy reconciliation information. So we just created a bigger, longer record. Who cares, right? It's big data, right? Cheap, and it's fast. And now all of that was there. And then the end user can pick what they want to work with. Do they want to, and this is my dial or my gauge here, do they want to work with all that data, whether it's meaning the original dirty stuff, or do they want to only deal with stuff that's cleaner? And there's sort of a level of, I guess, higher quality data. You can just turn your dial whether you want to use it or not. Because believe it or not, some people didn't care whether it was dirty or not. They only had certain types of things they were trying to get out of their data, like just a general trend. So they didn't care whether it was all the data in its dirty form or not. And that's fine. That was a small set of use cases. But then another set of use cases were, oh, I need to get this pretty squeaky clean because I'm about to make a business decision on this that is going to determine our next product line, all right? So we gave them all the dials. They could go squeaky clean or super clean, I should say, or pretty clean, or just show me use all the data, all right? Question, yeah?
So this data that arrives at the DDP.
Yep.
You deliver it in a different format than what you would receive it in? Well,
That's correct. That's right. So basically, how we're getting the data is all over the place, right? So that's the original data form. Then we add onto it what we call the conformed data component, which was more structured actually, but it was the information we wanted to add that was the data quality part. So in other words, really the way you think about it is, I've got a piece of data that's coming in from a data source on the big data side. It may correlate to something like a customer name. And on the conform side, we put the correct customer name that it matched to, that we have in our master data management platform. We also put some additional data, like maybe their address and things that we know about. We call that the conform data side. And then when you expose this data in the publish side, we expose it all. And then you tell the end user, well, all of the mastered stuff comes from these conformed data attributes. And then the raw data comes from the unconformed ones. And then they just use what they want out of that. All right? So it was really amazing, actually. So cool stuff. And so we want to be able to spin that off and deliver it for whatever purpose. So, and the traditional thing for this company I was doing this for, they used analysis services in a big way. So we would spin off hundreds of cubes every day off of this stuff, and for all different purposes, for different groups. Okay, so there's some key things that you also need to understand that became available to us, and actually we knew we had to deal with. One is taxonomies, all right? So you've all had to probably deal with taxonomies, where basically from all these different data sources we get, we have things that reference things that we can't use. But they probably map to something that we can use. That's why you build taxonomies. So you're doing that for consistency and accuracy, because what we publish has to be consistent. You can't build a cube on something that has 20 different ways to call a certain computer, all right? You've got to actually resolve that. Otherwise, you get 20 pieces of data all scattered all over the place under different names, and you can't actually see what's going on, all right? So taxonomies actually became really important to us. How to basically, bring things together in what we needed to call them. So if we saw like product names of computers, like this one, and this one, we really only wanted to ever be able to see that through this name. Or whether it was, legal entity references, or whether it was, even internal product architectures, all right, that we needed to represent. And so we created the mappings, the taxonomies for this, that then ended up becoming part of that conformed data. All right, so now you have that available to you, so you can spin cubes off of Super X4 series, and you never could do that before, because we had the data only in this other unresolved form. That was an amazing thing, because now you actually are reporting on the right stuff. All right, so that's part of data quality, by the way. The other thing is standardizing data and defaulting it. So for instance, we see parts of, these examples, street, and street, all right? So we also were able to utilize a standardization concept that we embedded in that data quality as a service that then said, well, how do we want to always look at street? And then we would actually make that part of the conformed data results set. We'd have the conformed value, or where we did these kind of things, or when data was missing, all right? We were able to default it with the missing value, all right? So this is just an example of filling in the address. Question?
So how did you achieve that? Did you use, like you mentioned that before, like AQS, do you build some knowledge bases?
That's right. So yeah, and there are actually a lot of great APIs out there that you can just call. So Google, believe it or not, is one of the ones that we're using. So they've got some APIs. I can feed it this address and come back with the zip, all right, instantaneously. And you'll see where this is interesting. And when you think of big data, you think of huge volumes and numbers. It only hurts up front. Later on, I'll show you, it gets easier and easier, all right? Great. So accuracy also means completeness, all right? So that's the moral of the story. So then I need to check my time here. I have until 11:30. Okay, shoot, better get moving here, Paul. So one of the things that we'll have to do here too is reconcile hierarchies. Now, a lot of the data coming in was product data from around the globe, point of sale stuff. So, and it often falls, depending on the manufacturer, falls under lots of different of their product hierarchies, all right? And what we needed to do internally was basically normalize this or have that reconciled to a single internal structure so that we can use it from a marketing and finance point of view internally, all right? So this also was possible, all right? Same with concepts of synonyms. We had to build up synonyms because we use those in the matching process. I can't match these together, they'd match poorly. But if I just do it, say to use synonyms as part of my matching strategy, it'll always get converted to this first before it's matched, and I'll come up with a better matching concept. Same with products. In enrichment, here's a great example. These products, as they come in, they have no other data with them, but we know what this footprint looks like, so we enhanced our big data platform to include these other attributes. All right, you with me? Of course, you may do other enrichment. So I think the biggest problem was this problem, all right? If you do have a data steward, maybe you don't, so it's even a bigger problem. You need to find out how they can affect this data coming in. So this is how, if you don't do data quality as a service, this is what their paradigm is. However, if you introduce data quality as a service, they have one place they can go and manage and manipulate and to work, because it's all coming through one place. So here's actually what we did, all right? I'm just going to build this out, and here's the capabilities that we used. So basically, we take in raw data, like customer data, bring it into our data staging data acquisition platform, then determine if it needs to be mastered or conformed. How do we do that? My next slide will show you that. But basically, you've got to figure out, do I need to master this piece of data? You don't need to master everything. It's only what needs to be mastered. Initially, everything. After that, not. I'll show you how that works. And then you feed back into the conformed data results for that, in this case, this customer, from this platform. And it really goes this circle, all right, right here. And then the engine that we use, the capabilities, we built out using an MDS platform. And for those that know MDS, there's basically a big storage. This is where my customer data would be, my customer master data, my product master, whatever entity concept. I'll show you the data model in a sec. But then there's also a staging table concept with it. This is how you introduce new data into the master, all right? And then there's this other product called Prophecy. Who's heard of Prophecy before? Some of you. Anybody have Prophecy? Okay, one hand, all right? So are you using it this way? Actually, Prophecy, the product is Maestro, and they've actually just upgraded it. It's now lost the Maestro name, and they have capabilities in the cloud or on premise. But the prior versions to what their current release is were tightly integrated into the MDS platform. Actually, the creators of Prophecy product are the ones that actually originally developed MBS, and then Microsoft bought it, and then they spun off into another company, all right? And that's often how life goes. But your data steward will always only work from this platform and get everything, so they don't have to go and worry about all those data sources. They get it in one place, and only what needs to be attended to is able to ingest also all that internal master data as part of this picture. So I'm plugging it in, all right? This is what we did. So then after the conform data comes back, you push it into this data delivery platform with only what you want to move forward, and that's what you use to publish it out. This actually is a simplified version of a live implementation, all right? So let's talk about some of the results and the nuances here. So as I was suggesting, when you first get data, and you've never plugged data quality as a service into this, you have to basically master all of your data. That's what the left indicates. 100% needs to be sent off to deal with conforming that data. But the minute that's been done, so there's some processing time associated with that, any new data, let's say we get 10 million rows of new data a day from a variety of sources, that only represents a percentage of the overall population. And as you can see, as my lakes get bigger, that percentage gets smaller. You guys following me? So to me, that always makes me feel better. Like I know I'm not having to redo things, all right? And the key thing is don't ever master something twice, all right? And I'll show you how we did that. But even of this data that is called unconformed, it hasn't been mastered yet, what we also found is that we're basically asking the question, have we seen this before? So have we seen this product before? Have we seen this customer before? If we have, we don't have to master it. It's already been done. And we have all of the conformed data already in our data lake. And only for that stuff that we haven't seen before do we push off to the data quality service. This diminishes over time. Question?
What if you change your master data? For example, you change your hierarchy.
Yes.
Then are you going to push those changes back historically as well? Or just new data?
You can choose to do that, all right? We actually had a process of going back and revisiting that data, all right? But in general, you obviously can't be right, 100% right when you're creating those. And so you have to understand that we had some downtime sometimes to reevaluate the mastering, all right? But wouldn't do it very often because we did a lot of analysis up front in order to make those determinations. But we'll add new product hierarchies into the mix, for instance, and we have to include that. That's also part of what we advertise. We'll say, okay, product, on point of time, here's what we were dealing with, and you have that data available to you in that, with that mastering, essentially. But it's a really good point. We did have to deal with that. So the key here is, we saw this before. That means we don't have to master it. Our master results are already, those conformed results are already in our data lake. But if we haven't ever seen it, meaning we just haven't seen it yet, we've got to go and master it. And here's how you do it, all right? So I'm giving you my secret, all right? So you guys can pay me later, all right? So basically, with the products that you have now in your hands, you can do things like diffs. You guys know what a diff is, right? That's basic stuff. You can say, oh, I've got this. What's different between the other thing? Well, basically, I'm comparing new data that's coming in, hence the raw, with my stage data, which I call existing. It's been conformed. If it exists, or if I get a match, I don't have to master it. But if I've never seen it before, I shoot only that to data quality as a service. So it's just like this, only do what I need to do. It actually ends up becoming less and less over time. And so here's a quick dirty example where I've got 10 million rows coming in. It's got these product references. Well, as you can see in the existing data, I've already got these two represented, so I don't have to do that anymore. All right? All I have to do is send model Z over there, because I've never seen that product before. You guys got it? Okay, that's actually the essence of the architecture, believe it or not, understanding that, because that helps, that either makes it possible or not possible. Here's kind of the results of that. So the red is products. Initially we had to match everything, all right? But it all had to, when we initially populated it. But basically, you can see that as time went on, we saw this data more and more, almost to a point near 100, actually, because we were getting all the product references, which means we didn't have to master that. So anything that had that product reference, we didn't have to mess with it. On the customer side, there was obviously 100% mastering to begin with, but then it kind of leveled off. It leveled off down low near 50, 60% because we were getting lots of new customers, all right? And we're always getting a certain percentage of new customers every day, all right? So then that's fine. And there were some adjustments along the way, a couple of blips, we still don't know what those were. And then what the future is, I don't know. So let me check my time, we're doing well. So here's an example of some of the, now the next couple of slides talks about some key strategies that we want to make sure are in place. For the prophecy, the Maestro guy in the audience, these should look familiar to you. Are you familiar with the product at all, or you just know? Okay. Sorry? Oh, okay, got it. Gotcha. You're the consumer of that, right? So gotcha. So, but within the product, you have the ability to set up something called strategies, which is basically you're saying, how do you want to master something, all right? And it's actually a lot better than DQS or MDS on its own, all right? It's really a wonderful extension. If you haven't looked at this, you better, all right? So because they surface all the right handles and have a lot of additional things that they deal with, including be able to deal with things like the matching strategies and things like survivorship rules. You guys should know some of these things, what to use in order to build up a master record on something, whether it's a product or a customer. It also deals with something called match scores and thresholds. So basically, you want as much automation as possible. You don't want to overburden the data steward with having to approve when something may or may not be a match for, like, this kind of looks like that product, and you want to actually automate that. And so there's an ability to create something called thresholds, where it just automatically says, yeah, close enough. It met a matching threshold of something. Or it's something called soft matches, might need some review, or just no match means it really is something unique. Go and push it through data quality as a service. So here's a quick example of that, where I've got a product name, and I've got something called match group. Don't worry about that. But in parentheses here, I have the matching results. This is actually the value, the score. When it's 1, that means perfect match, all right? Sure enough, it's a perfect match. But if there are variations of that, the matching varies, right? And you can see that. And so really what you got to figure out is some thresholds. So for instance, the first line here I just put up is, I want that anything that's 0.95 and above just to be close enough. It's good enough for us. It's the same thing, all right? And it's so the software does it automatically, just automatically approves that and makes it part of the master record, all right? Or maybe you have a proposal threshold. So if it's above 0.8, let's say, like this one is, it needs some review for consideration. It's proposed. It's a proposed match. But anything below that, no way, all right? So here's actually what it looks like in the tool, where we've got match scores down this column over here, and then what's likely going to happen, all right? These are all MDS type of references. where we've got some customers coming in. Here's what is potentially going to happen. Some were auto-approved because their scores were high. See how that works? And you can also see the record sources from where the data came from. All right, fun stuff. The whole concept around master records, I'm guessing that a lot of you know what this is. A master record is something that is identified in the master data management storage, where it can actually be composed of pieces from other related records. All right, and this is the best representation of what that right data should look like, and that's what you push forward. That becomes the conformed data that you push back. There's a quick and dirty example where we've got a whole bunch of customer references. XYZ Corporation, my favorite corporation, and a lot of its attributes. This line in yellow actually is the master value, the master record for that customer, XYZ Corporation, and it actually got its data from different places. But that's the one you want to move forward and becomes the conformed data that you push back to your data lake. We'll talk about survivorship. This is the same thing. Fuzzy matching. Here's the algorithm for fuzzy matching. You guys know this inside and out, right? How can I determine whether it's the same or not, right? So this is a good example. There are other matching methods, but here's how fuzzy works, where it deals with basically the A and the B on the bottom tokens has to do with what you have and what you're comparing it with. The common tokens is the things that, as it's been tokenized, as these words or whatever have been tokenized, how many were actually in common. You square that, then the whole thing, after you've divided, you do the square root of, and then you get a wonderful result. And that's what that 1.0 or that those scores are based on. Here's a quick example of that. So if I'm comparing two strings like factor and factorial, they look pretty close, right? They are. In fact, I determined that they were 0.63. Close. This is using something called a token size. Token size 3 means that's how we're going to carve out the permutations, all right, in groups of 3, and then compare them with the other one in those same token sizes. That actually is part of the algorithm here. That's the top piece. The number of tokens, is what we square. And then in a calculation, here's an example of if we use 2-token calculation. All right, question? Nope, you're good? So notice that the 3-token, using 3 as a token, ended up with 0.63, but of the same thing we got a higher number when we did 2. Actually, the smaller number of tokens you use, like 2, is more accurate because you're separating little pieces out, and then you're looking through all the commonality. 3 is a little less. That's nice, except what you'll find is in big data platforms, in general, you want to go to larger token sizes because doing lots of little ones takes a lot of time, and it's really expensive from that point of view. So you got to figure out what's right with what you have. It's a little bit about thresholds. This is all available to you in the online for this presentation. If it's not there, apparently it wasn't there today, I can get you this. Just leave your business card with me or an email address. Just come up and write your name. So again, this is a little bit about the token size. These are the best practices size. If it's 3, you can actually adjust that within the tool and then determine matching. Here's how synonyms are represented. All right, you basically say, if I find any of these, replace them with this, and actually use that in the matching. It doesn't change the data. It just uses them in the matching so that you get a consistent match across anything that is really the same. All right, that turns out to be a really big deal. And here's all the different types of scenarios. Internal, if you're an MDS guy, you'll get really familiar with this code concept and the name concept of the statuses. And here's actually just a detailed explanation of what each of those are. I'm really after the data steward is one that will change it to approved when he's analyzed things, anything that is going to be proposed to him. All right. So really it becomes a really simple review, approval, and rejection part from a data steward point of view. And it's going to be a really small number based on what we only push to the data steward from that point forward. Okay, I got to keep going. This is what you're after. This is actually, I'm going to show you some of the real live results from this platform. So what we started with a data lake that was pretty dirty, 63% good data. The rest was crap. Okay, would you like to make business decisions on that? No, I'm telling you, don't do that. You do something about it. After the first month, we raised that to 78.1%. Getting better. And then after a period of time, I think it was 6 months, we were getting close to 90, not quite. We could never go any higher. But from a big data point of view, that's gold. That's huge. All right? So question?
How do the metrics for the bad data?
Good question. Here it is. All right? So basically, we measured 100,000 random samples from the platform. Initially, where we were seeing, and then analyzed it thoroughly. We had lots of duplicates, invalids, no, they're just trash, garbage. Valids were not garbage. And then other things we couldn't figure out what the heck it was, all right? So basically that ended up with a certain number of records of that 100,000 that we couldn't deal with because they were crap. And then the remaining population, which was 63,000, was good, and we didn't have to do much with that. So this is kind of how that broke out. Here's what the result was. Here's what we changed it or cleaned it up to. That's a nice, pretty blue value, all right? That's what our goal was. But we couldn't get any higher. Don't expect that, all right? It isn't going to happen. Here's actually what that looked like from a technology deployment point of view. It's all done on the Cloudera side. We're using Hive's Scoop to manage and move data around and to do the diffs. And then you can see we moved it over into the data delivery platform. And it's at that point we push it off into whoever wants to consume it downstream. Question?
So that means you use Scoop to take the data from your prophecy
Yes.
from a database and pump it into the lake.
That's correct. Yep. So it's a great movement and tool, and you can do lots of fun stuff, all right, with that. So, and then you just pump it into the data quality service, actually answering your question, and this is obviously what the service comprised of. So, and then that's a happy data steward, and I actually have a lot of, I wasn't going to go to all these, so it's good I can skip them. This is the underlying data model, by the way, to MDS. You guys familiar with that? Its entities are really the key, models and entities are the key here, where that's where you represent a customer concept or a product concept. They are entities. It's a really nice, robust data model. And then you can also define things like hierarchies here to utilize that, and then all the attributes and so on, and business roles. How you surface the data out of MDS is through something called subscription views, all right? So that's how you get it back, visibility. Now you get the data, the raw data plus the conform data. We just exposed it as a subscription view, sucked it out, put it back in the lake, home free, all right? Yes, quick one.
Using MDS, DQS, is that something you feel Microsoft's going to continue to push?
Well, first of all, we weren't using the DQS side, only the MDS side, because that's where the bulk of the foundation is. DQS, didn't show you any DQS here. That's where we're using the prophecy capabilities, far better than the DQS. Okay, that's right. So one thing we also didn't do is I crossed it out here. We didn't do what is called harmonization. You guys heard that term before? Basically, when you master something, you have the right value now. And in an enterprise environment, you want to put that right value back to the data sources where it came from, like in your CRM system or your ERP system. Harmonization allows you to do that, all right, to push it back. We didn't have to do that because data lakes are read-only, right? So forget about it, all right? So that's why I crossed it out here, all right? But that's normally what you would get when you'd go full board master data management. In summary, understand your processing data requirements. You want to get data quality in there, veracity, right? And then you obviously have to be able to fulfill what your company is requiring of you. Give them better data, all right? Plug this in, get your veracity all worked out, make that investment. You will benefit from that forever. You will also be held up on a pedestal from that point on in life, all right, at your company. I can assure you. And just a reminder, big data isn't just Hadoop, all right? So be willing to look at other things for other purposes. DQAAS can be plugged into any platform, all right? So whether it's PDW or Teradata, what have you, or your enterprise systems, all right? It does the same thing well, all right? Great. Thank you.